Hello to everyone who is here live and everyone who watches this recording after the fact. It is myself, Hannah Daniels, and Jillian Dale here today with Meaningful Math. So we're going to be talking about how to create authentic math activities, and we are going to be highlighting a little bit our two different Labdisc products, our full-size GenSci Biochem and Biro or Visio Labdiscs and our smaller Explorers, but we will be sharing lots of good tips. So even if you don't have these, we are glad you are here and you will find lots of good info in this session. So this webinar, this podcast is brought to you by MimioSTEM, which is of course the company that makes and distributes these awesome Labdisc products, as well as some 3D printers and MySTEM Kids curriculum. So those will come up in our conversation, but we always try and share things that are useful to everyone. All right, so Jillian, I just want to kick this off with, you of course have expertise in the classroom. So you know firsthand the pain of, when am I ever gonna need this? When am I ever gonna use this? Am I right?
Yes. Oh yeah, absolutely. Yeah, it's really important for students to feel like what they're learning matters, or else, kind of the drive behind it goes away. So when we can make it as authentic as possible, it's just going to benefit the students more. And then the teacher's approach to it, it's going to be more successful as well. So anytime you can really highlight how it's going to be used in real life, that's always going to be a good deal with the students.
Yeah, I mean, I completely agree. I have a little bit more limited background in terms of actually working directly with students, but I see it with my nieces and nephews when I, help homeschool them. I see it when I've done some co-teaching and things, and it's just, yeah, I mean, I feel it too. There were certainly points in my education growing up where I'm just like, I can do it,
Mm.
but why?
Yeah. Yep.
So I guess one of the things I want to start with is, I know you did some cool research on, just how important math is, because obviously the why to us as adults is more clear because we start using math in our daily lives, in our careers, but there's some real struggles with that. So why don't you share some of the data points you found when you were doing some research?
Yeah, definitely. So when I was doing some research, and this has kind of always been in the back of my mind because I used to run a program called STEM for Girls. But there's a huge disconnect between girls in STEM careers and math related careers than there is for boys. But the achievement gap is honestly, it's getting wider. So if Hannah, if you want to share your screen,
Yeah.
we can talk about some of those stats that I found. So I was a fourth grade math teacher, and my students were pretty much all over the place, especially after COVID. Very, very large range of academic abilities in the classroom. I may be teaching some kindergarten standards, I may be teaching some fifth grade standards, but it was all encompassing in one fourth grade math class. So what we found is that 39% of fourth grade students were proficient in math, and the numbers kind of dwindle as we go into the higher grades. So by eighth
Oh,
grade, 28% of students are proficient in math. And then by 12th grade, only 22% of students are proficient in math. And what we mean when we say proficient in math, we mean at the average state level test scores, what students are scoring. If they're scoring at grade level or above grade level, they are considered proficient in math.
gotcha. And that is, I'm assuming, based on the national standards or national regulations, or is that sort of state by state? Do you know?
Well, you can get data from both points of it, actually. So some of the data that we had found was, this was actually from a federal survey.
Oh,
So this is coming from federal information, but then you can find other information as well. So we ended up, we were trying to, when Hannah and I were thinking about like, why is this happening? We were thinking like, what could students be thinking that's preventing them from pursuing a career in math or a STEM related career? 58% of students do not believe that they are intelligent enough to pursue a math related career, which to me blows my mind. Over half of students believe at before 18 years old, before their brain is fully developed, that they're not intelligent enough to pursue a career that interests them in a math related career, that needs to change, and it needs to change by exposure to authentic math tasks.
I completely agree. And this actually, so my husband has this pet peeve that I hadn't really thought about connecting to this, but his pet peeve is people just somehow it being culturally acceptable to just be like, oh, I'm really bad at math. And that is something you hear people say all the time. Like, sure, they're not in a math field. So they just say, oh, I'm not good at math. That's not my skill, whatever.
Yeah. Hmm.
And we just accept that as a society, as if math is not a necessary skill for everything. Some level of math is necessary for life,
Yes.
whether
Yeah.
it's just shopping or playing board games and needing to keep score, or, certainly any number of levels of higher math too. But why do we just let people, it tells students that adults can get by without this skill. So why
Mhm.
focus on it?
Absolutely. And I can't tell you how many times I've heard a student, younger than fifth grade say, well, I'm just not a math person, or math just isn't for me. And it's like, oh, it is though. It's for everyone. We just have to figure out what works for you.
And it's not that math is going to come easy to everyone or that
Right.
it's going to be your strength. So you might not be a math person, but that doesn't give you an excuse not to figure it out. Just like any other life skill. If you're bad at driving, you can't just be like, it's not for me.
Right.
Oh, actually, honestly, if you were bad at driving, I would prefer you say it's not for you and you try to avoid doing it because
Yeah, public transportation it is.
good luck in this country. So, yeah, I mean, I think we're obviously preaching to the choir. If you're coming in here to listen to this webinar, you are math folks. You understand and appreciate, same as us, how, important it is to give students that confidence and to not let them just get by with saying they're not good enough at it. So, I know we really wanted to talk a bit about techniques and skills for actually how do you get students, especially when we're working with widely different proficiencies. Uh, so what were some of your techniques you used when you were saying you were teaching everywhere from kindergarten to fifth grade standards? So how did you tackle that? How did you help students gain that confidence?
Well, the only way that I knew that what their academic levels were was from the data. So utilizing the data was absolutely essential for me. So before I became a teacher, fun fact, I used to work for the federal government and I was a financial data analyst. So I used my knowledge of data and just applied it towards the classrooms. So one of the things I had done for the government was process improvement. So looking at specific operations and then figuring out how we can improve those. I applied that exact same knowledge when I moved into the classroom. So I'm using students' diagnostic information, I'm using informal and formal assessments, trying to figure out where exactly they are academically, and then also what kind of learning style works for them. So the more data that I had, the better informed my instruction was, and the more I could cater it to student specific needs, which it is a lot of planning, in the long run. But when we're talking about student achievement and individual growth, it's worth it. It's 100% worth it.
I agree. I guess my follow-up question for you is how do you find the time? Because that is a huge question for teachers.
I mean, utilize the tools that you have. So don't try and tackle on literally everything that you can, but utilize the tools that you have currently. So learn what those tools and resources are, and then figure out how you can actually utilize them. We don't always have to reinvent the wheel. We just need to be aware of what our resources are and how to access them. A great resource that teachers could use is AI. AI has very, very powerful tool for helping with data analytics, and that could be a great way to help form some instructional decisions in your classroom.
Yeah, that's a great suggestion and actually a perfect promo for next month's Learning Lab. We're going to be talking about AI. So Jillian may not have even known that when she gave me that perfect plug. Uh, But yeah, I find I've been doing a fair bit more of data analytics in my role here with Mimeo STEM lately than I've ever had any use for before. And I thought I was decent at Excel until I had to do like deeper data in it. And I have been relying so much on ChatGPT to help me write Excel formulas. And like, I'm not even getting it to do the analyzing, I'm just helping use it to organize my data. And I think that is, such a great tool that we have now that I can't imagine having to do some of the things I'm doing now 5 years ago.
I know. Yeah. What was life before AI?
I'm pretty sure I remember it.
Now, Hannah, I know you write a lot of the lesson plans on My STEM Kit, so do you have tips for creating lesson plans that offer a wide range of skills?
Yeah, so I think one of the things that I really focus on for hitting a wide range of skills is partially in terms of thinking about it differently. So this ties back to making it authentic as well, is if I can tie in any other subject, I will. If I can integrate social studies, language arts, science, art, any of these fields, what it's going to do is activate a second part of a student's brain and get some students more interested. Obviously, you're not going to find one topic that's going to universally get every student in your class interested. But maybe it's you've got kids who love sports. You know how many data things you can do about sports?
Oh my
Baseball,
gosh,
my
yes.
goodness. Yeah. You want your students to build a March Madness bracket, build a comparison of the best baseball player who's ever lived. Cool. Okay, but now you have to back it up with data. Why are you choosing that? You can't do my March Madness bracket system nonsense of pitting the mascots against each other. Not allowed. For the record, my bracket did horribly this year, as it always does. Um, but yeah, like if you can tie in sports that way, if you can tie in, I do a lot of things that tie in like social studies or science. I actually, so back when I worked very closely with LM or with not LMU, that's my alma mater, with FSU, that was our original curriculum development team. And we had this rock star pair of curriculum developers who I really took a lot of inspiration from. Uh, Jim and Carrie, one was a science guy, one was a math gal, and they just perpetually worked together to create integrated lesson plans. So they're really the ones who taught me how much math you can do through a different lens. Like Punnett squares are inherently math, but I wasn't ever taught it that way. And then in terms of getting different grade levels interested, I find the more fun you can make the lesson in general, the more students will be attached to it and they'll be able to do it at their grade level. So you can do differentiated instruction, differentiated worksheets. Sometimes I'll do that if I'm writing a lesson plan that can be used across multiple grade levels. But some of the things I've found, especially just from practice, was I got into tutoring a family of refugees from the Congo a few years ago. So this is them. And these amazing humans had not had any formal schooling. And you can see they are ranging at the time this photo was taken, somewhere from like about 3 to 16, I think, or 3 to 15. And they'd had no formal schooling, which meant you have very different age levels. Some of them are just learning to count. Some of them are being thrown into a sophomore year of high school and having, yeah, it was real tough on some of the older ones. But what I found worked for them was just gamifying it.
Hmm.
So you can see over here, we've got Galula and he's doing math with bowling. He's using our 3D printed bowling kit. And, with the younger students, they're counting how many pins got knocked over. With the older grade levels, now they're doing decimals or fractions. Maybe you're doing subtraction. How many more do you need to knock over? Or you're doing 2 rolls and you're doing addition. How many total did you knock over? And it's the same basic thing, which is you take a bowling ball, you roll it down a thing, you count how many got knocked over in some regard, and then you do something with that data. We did another one with our 3D printed catapults where they were launching it into zones and graphing it and doing all sorts of data analysis with this. And this was not a formal school environment, so it was allowed to be a little bit more silly.
Mhm.
But I also started with just tutoring one of them. I was brought in to help one of them in my spare time. And suddenly, all of the other four of them started wandering in and choosing to learn math
Hmm.
because it was fun.
Yeah. Uh-huh.
So yeah, I love these children. They're wonderful, and you know they've grown up a fair bit since these photos were taken because they moved away and then I moved away. But yeah,
That
so
is
that's,
very cool.
yeah, they're awesome, and I think that was also what showed me in a real world scenario is how can I create a lesson that can appeal to and work for all these different ages, all these different grade levels, and so forth.
Yeah, yeah, I love that. And even if a school is not wanting to 3D print specific things, just for individual classrooms, that would be a great way to sort of create like a 3D printed library, so that, multiple grades could access the library and use it for different instruction.
Yeah, agreed. I think there's so many, like I see it with teachers all the time are telling me they took an idea from one of my lessons and then took it a completely different way, or they totally expanded or they adjusted it. And, that's really cool to me to see how the lessons I wrote get evolved and progress in a school environment.
Yeah, absolutely.
But I think one of the strong things I noticed with both of these examples I gave is that data is such a key part of making math fun. And data is not a word that generally inspires too many people out there to go, ooh. Your statisticians, your actuaries, they might go, ooh. Even your stockbrokers, they like data. But it's not a word that the general population is excited about. And yet, I find it's one of the easiest ways to do that interdisciplinary stuff. And it's one of the easiest ways to make math actually feel real.
Yes, absolutely. And I love that you're connecting other subjects to it too. When I was teaching fourth grade math, I would do 9 weeks of social studies and then 9 weeks of science. So my kids would most likely forget what we talked about 9 weeks before. So if I could, interweave the concepts of science and concepts of social studies throughout my math lesson, interspersed through those 9 weeks, it's going to make some learning actually stick.
Yeah, I mean, we had a whole previous podcast on that where we were just talking about how to create these interdisciplinary things and how beneficial it is. But I think math is one of the easiest subjects to make interdisciplinary,
Absolutely.
especially with science. Like those two are just so well suited to work together. Or engineering. So like engineering design, anytime you're doing 3D modeling, you're actually doing math. You're doing a lot of math. You're doing, you know, measurement, data, geometry, data lesser. Depends on if you're actually collecting data with what you print and then do iterative design, because that's all data driven again. Uh,
Hmm.
but yeah, you can't 3D model things for the real world without some amount of understanding of basic shapes and measurement. And if your students are terrible at the metric system, guess what? They get to use millimeters, so they're going to learn. So, yeah, I mean, I think that's just one of the easiest ways to do that. So, okay, you were talking about how you used data as a teacher. Do you have any tips or tools or things you like to use that had your students collecting data?
Um, well, data informs your instruction. It's really hard for you to just, progress through your pacing guide and not think about your student data without leaving your kids behind.
Mm,
So we're all familiar with the phrase, teach to the test, but that's just not reasonable in the classroom today. Individual student data is absolutely essential when you're making instructional decisions. And we want kids to grow, but in order for them to grow, we must understand where they are at. So my recommendation is to do some sort of diagnostic assessment. So a lot of schools, the math curriculum, they probably already have one, but go in and do an additional assessment yourself just by having a conversation with your kids. Go in and ask them, how did you solve that? Show me how you solved that. And then be quiet. So you can just listen to what they're doing, what they're explaining to you, and you can start to get some ideas of, okay, well, this is what, this is how they're understanding this. And then we can start building from there. You can use those skills, the knowledge that they already have, and start building upon it. It doesn't make any sense to teach the standard algorithm if students are lacking the basic fundamentals of number sense. So, for example, I could not start teaching long division in my fourth grade math class because I had so many gaps in the number sense in my classroom. And so, one thing that I chose to do with my students is I gave them a giant sheet of graph paper and I said, here is your problem. And it was like, a 4-digit number divided by a 1-digit number. And I'm like, okay, division is what? Breaking things into equal groups. Figure out how many equal groups you can make of this, and then just show how you got all of your work on the paper. Okay, by the end of it, they used about 10 pieces of chart paper because they're making, huge groups. But by the end of it, they started to understand the standard algorithm. They're understanding why they're taking chunks out of the number, and leaving another number up top of how many groups they were able to take out. So things are starting to piece together. So take a step back and utilize and just have a conversation with your kids. How are you solving this? Show me. What ways are you doing it? Because it may not make sense to us because that's not how we grew up learning math. But now, we're teaching it in a very different way because our students are all over the place. So just have a conversation. Ask your kids, how did you do that? Show me what you did.
I think listening is undervalued with how much information you can get out of it.
100%. 100%. And you'll learn so much about the kids too. I mean, you'll learn like, okay, is their friendly number that they go to, is it fives or is it tens? You're going to learn that in the conversation. And then you're going to learn other skills that you need that like you can build off of what they already know to take them to the next level. But it starts with that data piece and a simple conversation.
I also think so. One of the things we write into a lot of our lessons is student discussion, breaking them into small groups and letting them discuss and debate within themselves. This is something we do a lot of in our like K5 geometry unit. It's like, is that a triangle? Well, no, because that edge is curved. But letting the students sort of duke it out tells you as a teacher, as you're just wandering around listening to them, what they're grasping and what they're not.
100%. Every single one of my math classes started with a math discourse where we're just talking about math. We're not writing anything down. We're not solving anything. We're just talking. We're just having a conversation. And it gets kids to not be so nervous to attempt problems that they may not know yet or that are unfamiliar to them. So just a simple conversation.
That was something I also, have learned over the years is if you can make it, if you students aren't going to need an eraser, they're much more interested in submitting an answer.
Yes.
Low
Yes.
pressure is better for actually hearing where they're at.
Yep. Yeah, that's why when I gave them the chart paper, I only allowed them to use markers because I did not want them erasing anything so I could see all of their work.
Smart. So, okay, we did mention that we would highlight some of the Labdisc type features in this session. And I think, everything we've done to talk about data and all of these sort of broadly applicable things really come to shine when it comes to these particular two products that we offer. Because so we have two different models of Labdisc. You can see our smaller Explorus and then our larger Labdisc. And this one actually comes in 4 different varieties. But at the heart of what they are data collectors. And just collecting data is only step 1, but what you do with it is where it really, I think, starts to shine. So anytime you're doing science experiments, not every time, but most of the time when you're doing science experiments, you are often collecting some sort of data, whether it is, what is the temperature outside? Or what is the water quality here? It looks like this one's got a pH sample in it as well as a temperature probe. So I'm not sure exactly what experiment the student was doing other than that they're testing water quality. They've got, different liquids here that they might be putting in or resolving the water quality, testing it out. But it's one of those things where you need to know what to do with the number you're getting. So I absolutely love these two pieces of hardware from a data standpoint, from a math standpoint. We market this Labdisc as an all-in-one science lab, but to me, in so many ways, it's an all-in-one math lab that just happens to have science attached. So for those of you who may not have one or both of these, because I know some of you have one, some of you have the other, some may not have either, but so you can understand a little bit of what's included in them. They each have a variety of sensors. So the Explorers is got light, distance, temperature, sound level, as well as like voltage. And then this one does a whole bunch of other things. We've done sessions highlighting how it can do art and music and animation and coding and control and all sorts of, yeah. So this is way more than just a data logger, but today we're going to be focused a lot on the data logger component of it. And then the lab discs, depending on which of the 4 different versions you have up to 15 different sensors. So the GenSci one here has pH, temperature, humidity, GPS, light, voltage, air pressure, so many different things. So whatever kind of science experiment you're doing or whatever kind of math thing you want to do, they have sensors for it. Jillian, do you think that feels like a good overview of what the 2 different products are, or do you have anything to add?
Absolutely. Nope, you did a great job.
So, these are tools I very much like, and one of the reasons I like them so much is because of what you can get real time. So this is the Globi Lab interface here. So that's the one that works with the larger GenSci. We sort of direct this one more towards 6 to 12, but it was a K-12 product for many years, so there's loads of lessons plans for it even at the younger grades. Whereas the Explorers device here, we optimize more for K-8, and Jillian will be showing this software a little later, or I can as well. So with this, you're going to find all of these sensors are hidden underneath this little cover here, and I can come in here and collect all sorts of data simultaneously. So, all right, distance, light, humidity, sound, sure. This is not going to be a real science experiment that's going to mean anything, but it will show you how the software works. So I'm just going to click exit and click run. And as soon as I do that, let's move my light sensor up towards my light here, or better yet, towards the window. There we go. The blue line went up. You're also getting my talking going up and down in the gray line. Distance is going all over the place as I move this thing wildly around. And let's make the humidity go up by sticking my hand on the humidity sensor. So now the green line is going up. So let's pretend that this was an actual meaningful experiment and not just a whole chaos of random sensors that don't have to do with anything together. If you look at this, there are so many data points you can do. So if you're talking middle school, you can take any one of these lines and do mean, absolute, mean, mode, median, absolute deviation. For high school, you can do standard deviation. One of the cool things I love about this software is the ability to actually have it do some data analysis for you. So if you're using the software, you can get insane quantities of data, and you are not going to have your students sitting there and calculating, let's see, how many data points does this have? 222. I don't know any math teachers out there who are going to make their students figure out the average, the mean by hand for 222 data points. Please don't. That's mean. Unless you're at least allowing a calculator, and then it's more acceptable. But what we can do is actually like just click on this little calculator here at the top, and it will tell me, here's my minimum data value. And this is looking at the distance. So let me actually select one of my other ones. I'll look at light here. So now I can see the minimum for light, the maximum, my average, my standard deviation. There's my number of samples. And I can have it do all of that for me. Now, if you're just reading the data off the screen, because everything is coming here off the screen, whichever, data point I've selected, I can click on these different guys and see them. Now, you can have students do it by hand, and it's super important that students still do physical graphing. They still do their own, calculations of mean. But when you really want to replicate what a real world math looks like, that's where something like this is great, because students feel like real scientists when they're working with something like this, because you can go out and use this. I've used this for all sorts of real science around my house or on different experiments, from testing pH of my soil to my electricity was doing weird things one day. So I plugged in the banana cables, and I'm going to go figure out, oh, I have low voltage in this house. Fun. All sorts of real world things. Oh, when my fridge was dying, stick this in, track the temperature. I can see, whether or not my fridge is staying cold or not. Spoilers, it was not. Yeah, that was fun. We went through like 2 fridges in a month because the new one we got broke too.
Oh no.
All sorts of bad luck, but man, this thing came in real handy at that point. So one of the other cool math features of this is actually the ability to even generate something like a linear regression. So I can figure out the real data here as the humidity increased when I put my hand on it and how quickly it was increasing. So you can use the tool to generate data, whether you're doing it manually or all at once or little bits at a time. But then you can use the software, especially when you get into large data fields, to actually get some useful pieces of information. So that's the big thing, right? Is how is the data useful? What does it mean? Because a big data table is so hard to take in, for me at least. I need something visual. And you can export from this into Excel, and you can do graphing and such in Excel too, which is a really useful skill, or Google Sheets or whichever sheets you use. I always use Excel, so that's my default. But this is just one of the things I love about how this device makes doing the math easier, and it makes it feel more applicable.
Mm-hmm. Yeah, and when the kids are, when they're coming up with the data themselves, rather than just pulling it out of a table in a textbook, it's a lot more meaningful.
Oh yeah. I mean, and it doesn't have to be with this device. You can collect data in so many different ways. They can be using an old school thermometer, but they collected it themselves, which means they're not just doing the formula to figure out the mean or the median. They're actually having to think a little bit more critically about why that matters and what that means in this scenario. And I think that's huge.
Absolutely.
I also forgot you can add annotations. So I can say something like held an over humidity sensor.
Ooh, can you add a picture?
I can, but who knows what picture I'm going to find.
Oh gosh.
Ah, excellent. It is in my solar eclipse photos from back when I did a very cool Labdisc solar eclipse experiment here. So it's like, am I going to go into downloads, get pictures of, broken 3D printers that I was doing support tickets on? It could be anything, but nope, it's an eclipse today. So theoretically, your students could take photos with their devices and add these images in as well. So this is the kind of graph you can generate like adults do when they're presenting. So I think students getting a chance to, if you think about like science fair, they come up with something that matters to them, or you help prompt them with how can we improve this? What is our local water quality? Are we having runoff issues? What do pesticides do? What do fertilizers do? Can you test that? Those are all water quality related things. But you can also we have an awesome story of some elementary students in Moscow. So they have this device, and Moscow had just built a whole bunch of sound barriers in their neighborhood and spent all this money putting them in. And the students were like sitting there going, I don't hear a difference. I wonder if there actually is one. So they use the sound sensor, which is again available on either of these. And they used it because they had this one at the time. And they actually used the GPS built in on this. And they could track their movement on a GPS map on either side of the sound barrier. And it didn't make a difference. The sound barriers weren't working.
Oh boy.
Yeah, so they had real data then that they were able to show and present. And I'm not sure how they got connected, but they got enough attention for their experiment as an elementary school that, like, the mayor of Moscow came out to look at their data and they actually affected real change in their local community because they were going to install more of these. And instead, they went back to the drawing board to be like, okay, let's spend our money where it actually is going to make a difference. What can we do differently? What other companies are out there? How can we make sure that our money is being used well?
Oh my gosh. Give
Yeah.
every kid a Labdisc, change the world.
At least it changed that one little neighborhood in Moscow. Yeah, so I mean, we hear stories like that all the time. The photo I had on that slide with the girl doing the water quality, that's actually from an experiment in Uruguay where they were doing all sorts of different water quality testing all over the country and comparing their data. Like they got connected with other schools and this it was I think part of a private school enterprise that had locations all over the country. And so some of them were looking at farm water, some were looking at beaches, some were looking at inner city and like seeing how the water varied across the country and ways that they could improve that. So, like inherently, anytime you're actually trying to make real change, you're actually trying to do something real, the data is so often at the heart of it. That's how you convince people.
Yeah, absolutely. Absolutely. It makes for more authentic learning when it's real examples. It's not just I'm going to the store to buy some seashells, things that don't matter. I'm going to buy 42 watermelons. I remember that is always coming up in textbook. Who buys 42 watermelons at one time? But it's on
How
every
does
stick.
one carry 42 watermelons?
I don't know. Oh, goodness.
So why don't you share a little bit about the Explorus and its software, if you don't mind, and specifically showing how this can be used for elementary, because I was giving a lot of more middle and high school examples.
Yeah, would love to. Okay, so this is the Explorers software, and this is more geared towards like kindergarten through fifth grade level. There's a few reasons behind that. So you have a couple different modules that you can click on. The science module is going to be very, very similar to GlobiLab, but built a little bit more for elementary.
Mhm.
So you've got two different components. You've got the sensing component and the data logging component. The data logging component is very similar to what Hannah had just showed us with GlobiLab. It just looks a little bit more kid friendly, if you will, a little bit more colorful. So in here, what you can do is you can, again, choose which sensors you would like in an experiment. Notice that we don't have as many sensors on the Explorus as we do with the Labdisc, and there's a reason for that. They're not all needed and at the elementary level. Most of the elementary science can be covered by the 5 sensors that are on the Explorus, but there are some additional options as well. So you've got light, you've got voltage, you have external and ambient temperature. You have distance, and then you also have the heart rate, the pulse and the speed, and then you have sound as well. So again, you can go in and you can set your sampling rate and then the number of samples that you want. And then one feature that I really like about the Explorus that is a little bit different than the GlobiLab is this predict feature. So on this sensing part, I can go into the predict feature and you'll see the dotted line here is where I predicted my experiment would go. Now notice the bottom line down here because I'm actively running an experiment. Well, as I am using this distance sensor, I'm going to hold it up to the wall and then move it closer and farther away to try and match up with the sensor or the prediction that I already have made. So if you notice, this gives you an understanding if your kids understand what's going on in a graph. So here I'm not doing so hot. I need to pull my explorers further away, at a greater rate of speed so that it can climb that higher rate. So it gives you a good indication of if your students understand what a graph is showing you. And then also with sensing, you have these wonderful gauges, so you can choose what visuals you would like to see, the number of them that you want to see. But notice there's no decimal places. Everything on the Explorers is in all whole numbers, which also makes it a little bit more relevant to the elementary kiddos. So no decimal places, just all whole numbers. And then you also have nice visual changes too. So you can see on the gauges that there is a visual cue change when I hold this up to my mouth, because the decibels is reading a higher one. The same thing with the distance here. And then the temperature, this color, it will make a color change here as the temperature changes as well. But my absolute favorite data point on this graph is the pictograph. And this is my favorite because every single state test, every single one of them, I don't care what grade level you're looking at, there's some kind of graph on that test. And at the majority of the time, kids kindergarten through third grade, they're still dealing with pictographs, bar graphs. Showing them some kind of pictograph or even a bar graph so that they're getting exposed to reading graphs, viewing data, analyzing the data throughout the entire school year is going to best prepare them for those state standardized tests. I know for me, sometimes data in our pacing guide, it came, April, May. Well, state testing is usually in March or April. So sometimes we had the chance to get to data before the state test. Sometimes we did not. But it was always on there. So if you can use something where the kids are learning about data throughout the entire school year, they're going to be more prepared for that test.
Yeah, thank you for showing that. I'm gonna steal screen sharing for just a second because you were talking about how wonderfully like visual that the software is. And one of the other things I love about the Explorers is how visual the screen is. So this is a GIF I took when I had a pot going. So at the beginning of it, I move it from ice water, the temperature probe, into an almost boiling water, and watch how the screen is changing. You can see the animation change. You can see the background change. So everything on the device itself is also just so intuitive.
So it's giving the kids more information too. So not just the numbers in the data, but also those visual cues. That's perfect for your emergent readers or even your ESOL students
Mhm.
where English is not their first language.
Absolutely. Now, I know we are running low on time here, so I do want to share a few resources of good places to go for just general data resources for you as a teacher. These were put together by Jillian for the most part. So these are great places to find info you can use as a teacher.
Yes, if you are currently doing math discourse in your classroom or teachers that are, the New York Times one, that one is a great one to add to your math discourse arsenal. Gives you a nice photo of a graph and then students can go in and they can just talk about it. One of the things that we always asked, what do you notice? What do you wonder? So that's a great way to just get the kids started. There's no wrong answers here. And I don't see any numbers on this page, so it shouldn't be super intimidating, to kids. They can look at it and they can just have a conversation about it.
It's actually really interesting the more you look at this.
I know, I was looking at it earlier. I'm like, wow, we're so tiny and minimal in this universe.
And concrete is not.
I know, nor are bricks or bacteria. Also, I'm a little alarmed by the amount of fungi and how much more fungi there is than humans.
The fact that there's more biomass of viruses than humans is to me far more disturbing.
Yeah,
So, this graph just prompts the conversation by looking at it. So this is one of the things Jillian found on the, what is going on in this graph. So I think, like she said, that's an awesome way to start a math class, start a day, get students talking. And then, you can actually find the real data and graph it in a different way or have the students look at the numbers and figure out what it means, depending on your age level. But even if they don't do that, the conversation is huge.
absolutely.
And then one final just general pitch, if you are doing any sort of coding, any sort of programming with your students, you are doing applicable math. And it's important that your students realize it. Like, you can keep it under the radar for a little while, but if a student tries to tell you they're not great at math, they're not a math person, and yet they're excellent at code, they don't get away with that. This is one of the best ways that students can learn code without realizing it, or can learn math without realizing it, because there's so much hidden math in code, just like there is in design. Like 3D modeling, code, these are some of the best sort of under the radar ways to teach math. All right, so this is our contact info. If you have any questions about the products we highlighted today, about any of the things we were talking about, you want those resources again, we will be posting this recording to our YouTube. That's our Mimeo STEM YouTube. You can find it and previous video podcasts there, or you can email us, like I said, for any more info. And be sure to join next week. Not next week, next month. This will be on Thursday, May 15th. We're going to go a little earlier in the day to work with different schedules. And Evan and I are going to be talking about AI, specifically how your students can use it, because we know they're using it anyway. So how can you make it beneficial to their learning and actually create some really cool experiments and activities that utilize students using AI. So I put the Zoom link to register there in the chat, or you can use the QR code on the screen.
Awesome. Well, thanks everyone for joining us.